All right, we're stepping completely away from the solid concrete and the neatly painted lines of traditional runways today. We're entering the fascinating, constantly shifting world of sea-based aviation. Welcome to The Explainer. If you ever watched a plane landing on a river or a busy harbor and thought, how on earth do they safely manage the chaos of an airport built entirely on water, well, you are in the exact right place.
Okay, let's dive right into this. Have you ever flown into an airport where the runway is literally moving underneath you? I mean, it sounds like an absolute nightmare for a traditional pilot, right? But for the folks at the controls of a seaplane, it's literally just another Tuesday. Operating an aircraft on water is fundamentally different from a conventional airport in almost every conceivable way, and we're going to explore exactly why.
So here's our roadmap for this explainer. First, we'll look at the dynamic airport environment. Second, taxiing without paved taxiways. Third, docking and mooring operations. Fourth, fuel, cargo, and passengers. And finally, navigating shared waterways. Section 1. The dynamic airport environment, concrete versus fluid. Now, to really wrap our heads around seabases, we first have to understand the completely unique combination of aviation and maritime procedures required to run them. Just think about a normal airport for a second. Aircraft move across paved taxiways and runways using fixed infrastructure. It's solid, it's defined, and it's highly predictable. But at a seabase, the operational environment itself is a fluid. It's constantly moving. The water conditions change continuously, thanks to wind, currents, waves, tides, and even just the wake from other marine traffic passing by. From the absolute second those floats touch the water, the pilot isn't just flying an airplane anymore. They're basically commanding a marine vessel.
Section 2. Taxiing without paved taxiways, the open water challenge.
Now, what's really interesting about this slide is how it maps out the intense operation of just getting the aircraft from the open water landing zone to the terminal. See those visual arrows indicating wind and current directions? Pilots have to constantly monitor those. Seaplanes simply do not have the luxury of perfectly paved yellow line taxiways. They have to maneuver directly across the open water, battling dynamic natural forces that are constantly trying to push and pull the aircraft way off its intended path.
To actually pull this off and successfully navigate across the open water, pilots have to master a really delicate balance. They rely on precise control of engine thrust and specialized water rudders, all while factoring in the wind direction and water currents we just talked about. Oh, and here's a massive detail. Aircraft don't have brakes on the water. Because they're battling these specific, ever-changing forces, taxiing on water can honestly be significantly more challenging for a pilot than actually flying the plane.
Section 3. Docking and mooring operations, the delicate dance.
All right, so here we are at the highly specialized docking phase, where the aircraft finally transitions from the open water to the actual terminal. If you look closely here at the docking zone, you'll see floating pontoons, tie-down cleats, and mooring buoys scattered around. Bringing a multi-ton aircraft into this confined space requires a serious dual mindset. I mean, the pilot literally has to act as both an aviator and a mariner at the exact same time. The aircraft can still drift so easily, so approaching this structure, it takes incredible finesse.
A really key piece of infrastructure here is the floating pontoon. Because seabases operate on bodies of water that are totally at the mercy of tidal shifts and changing water levels, your standard fixed concrete docks just wouldn't work. Think about it. The plane would either sit way too high or be completely underwater depending on the time of day. So these pontoons adapt beautifully, rising and falling naturally with the environment to make sure there's always a safe, consistent height for the aircraft to pull up alongside. But what happens when an aircraft isn't actively loading or unloading at those main pontoons? Well, it still needs a safe place to park, and that's exactly where mooring systems come in. Mooring buoys are basically anchored floats that allow ground crews to secure the aircraft safely away from the main dock. This does two big things. It protects the aircraft from drifting away in strong currents when it's just sitting there, and vitally, it frees up the highly limited docking space available at the terminal.
So, this delicate dance happens step by step. First, the pilot has to taxi carefully toward the docking area, making constant, micro-adjustments for the environment. Second, they have to coordinate closely with dock personnel, usually relying heavily on hand signals and radios. And finally, the aircraft is brought just close enough so it can be manually secured to the cleats by the ground crews. It's a real team effort.
Section 4. Fuel, cargo, and passengers, floating logistics.
Okay, once the plane is tied down safely, the clock immediately starts on the logistical turnaround and the energy dock side completely changes. It's a super bustling process. And this brilliantly illustrates the setup we're talking about. specialized marine fueling docks right next to manual cargo loading operations. Because we're not working on a massive, sprawling concrete apron, all of these logistical operations have to happen on specialized, really compact floating platforms. It's honestly a fantastic example of spatial efficiency and marine engineering working perfectly together.
Now, naturally, fueling an aircraft directly over open water carries some pretty massive responsibilities. Operators have to maintain incredibly strict environmental and safety precautions. They've got to carefully manage the fuel transfer to prevent any contamination of the aviation fuel itself, absolutely stop any potential marine spills to protect the local ecosystem, and aggressively mitigate fire hazards in what is obviously a highly sensitive area. There is literally zero margin for error here.
And as for getting the passengers and the freight on board, well, you definitely won't find any enclosed, air-conditioned jet bridges here. Everything relies on floating walkways, boarding ramps, and manual dockside loading. In fact, depending on exactly where the seabase is located, you might even see auxiliary boats and forklifts pitching in to haul cargo straight from the shore to the aircraft. It's a very hands-on operation.
Section 5. Navigating shared waterways, the broader ecosystem.
All right, let's zoom out a bit and expand our scope to look at the entire marine environment where all these operations actually take place. Take a look at the sheer amount of activity in this ecosystem. Seaplanes absolutely do not operate in an exclusive vacuum. They share these exact same waterways with boats, busy ferries, fishing vessels, and all sorts of recreational traffic. Operators have to carefully manage dedicated water operating zones, constantly keeping an eye on navigation markers and real-time weather data to keep everyone safe. It's a highly congested, complex airspace and water space basically mashed into one.
As you can imagine, all of this builds into an immense cognitive load for the pilot. They essentially have to bridge the gap between two completely different worlds simultaneously. On one hand, they need aviation awareness, following standard flight paths and communicating with air traffic control. But on the other hand, they absolutely need maritime situational awareness, reading water markers, tracking local marine traffic, and anticipating boat movements. They have to play by the rules of aviation authorities like the FAA and maritime groups like NOAA at the exact same time.
And keep in mind, all of that intense coordination is happening under the constant threat of unpredictable marine factors. We're talking about high waves, strong winds, suddenly reduced visibility from sea fog, winter ice, and dramatic tidal shifts that can rapidly halt or completely alter operations. Unlike a perfectly paved runway, water surfaces are completely dynamic. Because of this, strict operational flexibility and split-second pilot judgment are absolutely paramount for everyone's safety.
So, what does this all mean? Well, even though they're usually a lot physically smaller than major international airports, seabases function as highly coordinated, incredibly complex transport environments. They beautifully combine standard aviation needs with specialized maritime infrastructure, unique logistics, and intense environmental management. They are true marvels that require constant, real-time adaptation to the natural environment itself just to function safely and efficiently.
So the next time you settle into a window seat and watch your plane roll down a perfectly flat, painted stretch of concrete, ask yourself, could your pilot navigate a runway that's constantly moving, shifting, and actively fighting back? Operating an aircraft on water truly makes seabase aviation one of the most uniquely challenging and impressive forms of transportation infrastructure in the world. Thanks for learning with me today on this explainer, and stay curious.